In this video, we will be looking at equivalent algebraic expressions, and in this case, we'll be multiplying and dividing rational expressions. Good luck. Of course, we can't start without the joke. Why did the physics teacher break up with the biology teacher? Because they had no chemistry. So in this video, we're going to be looking at how to multiply and divide rational expressions, and also making sure that we state restrictions. Right, we're going to go back to basic fractions first. So in example 1, just so we can follow the same rules throughout the whole lesson, I'm going to factor first. Now you're looking at that and saying, well, how do I factor 4/5 times 9 over 8? Well, I can make 4 as 4 times 1, and if 8 is 4 times 2, I'm actually going to do that. So 4 over 5 times, and I'm going to change the 8 to a 4 times 2. I factored the 8. I found two things that multiplied to the 8. Now, I probably could have factored the 9 as well. It's 3 times 3. But I wanted to factor so that I could find things on the top and bottom that could cancel out. So let's try doing that. So this 4 and this 4, like 4 divided by 4 is 1, so they are effectively canceled. So that leaves us with 9 over 5 times 2, because each of these is now 1, so 4 divided by 4 is 1. So then that leaves me with 9 over 5 times 2, which is 9/10. So my first step was to factor and to find anything on top and bottom that could have been canceled out or divided out. Let's do the second one. Okay, so the second one is division. If you recall, when we wrote division, we rewrote it as a multiplication, and all we did was take the first fraction, 3/4, and then multiply it by the flip of the second one, so times 3 over 1. And then we just multiplied the tops, so 3 times 3 over 4 times 1, which is 9 over 4. So it's just some basic skills, things to remember as we move forward. Okay, so I'm going to rewrite this as 5a squared, and I'm going to change the 14 into a 7 times 2, big times here, and 7, and I'm going to change the 10 to a 5 times 2, a to the 3. And from here I can see that there's a 7 here divided by a 7 here, and a 5 here divided by 5 here, so I can cancel those. So on the top then I just have a squared over, and I have a 2 and a 2, so 4a to the 3. Now I didn't look at the a's at all, but you can see that I have a times a on the top and 4a times a on the bottom. So now I can divide out common things on top and bottom again. So a divided by a is 1, a divided by a is 1, and I'm left with, going back to blue, on the top just 1, and on the bottom 4a. Now I did the canceling of the numbers in one step, and then the canceling of the letters in the second step. So you can break it up if you need to. In example 3, where we have much more complicated looking things, but it's getting more complicated looking, but it's not more difficult. It's uglier, not harder. So what I'm looking at is I need to factor each part, each top if possible, and each bottom if possible, and divide out things that they have in common. So I'm going to start by factoring this. So when I factored a squared plus 4a plus 4, I got a plus 2 squared. So there's actually two of them, a plus 2 times a plus 2. Now I'm going to factor the bottom. Okay, so when I factored the bottom, I get 2a minus 5 times a plus 2. So the a plus 5 here is just a plus 5 here, And then I'm going to factor the bottom here, a squared plus 2a. That has just a common factor of a, so a squared plus 2a becomes a times a plus 2. Now I look for common factors both on the top and bottom, and I divide them out. So a plus 2 divided by a plus 2, this a plus 2 divided by this a plus 2, and finally I have left a plus 5 over 2a minus 5 times a. Okay, I'm going to look at the restrictions now. To do that, I'm going to focus on the line before I canceled, because everything that was here still counts. So I'm going to look at whatever was on the bottom, whenever it was on the bottom, if it could be equal to 0. So in this case, a can't equal 0. A can't equal negative 2. And a can't equal 5 over 2. Okay, so here's a division 1, but we know that we're just going to keep the first fraction, change it to multiply, and flip the second fraction. Look for anything in common on the top and bottom. 9 goes into itself once and into 27 3 times. 5 goes into itself once and into 15 3 times. I have common factors, those common factors on top and bottom. Looking at the x's, I have x squared here and x3 here, so both of these cancel with 2 of these, and this becomes a 1. So I can rewrite that. So I get 3 over 3x, and it seems I still have a common factor, so technically it's 1 over x, because 3 divided by 3 is 1. So 1 over x. Looking at the bottom, my restriction would be x cannot equal 0, and that's going to be true at all levels. The first thing we need to do with a division is change it from divide and flip the second one and multiply. The next step is to factor any possible things. So these can't be factored any further, but this can, so I'm going to have to factor this. We need to factor x squared plus 5x plus 6. All the other terms stay the same, so 3x squared over x plus 2, and then the 6x4, and I'm just going to factor this one, so I get x plus 2 times x plus 3 for the top. Divide out common factors on the top and bottom, so 3 goes into itself once and into 6 twice. X squared, 2 of these cancel with 2 of these, so I'm left with an x squared on the bottom. And then this x plus 2 and this x plus 2 cancel. I'm going to rewrite the whole thing. So after the canceling, I rewrite it as x plus 3 from the top over 2x squared on the bottom. Last step, restrictions. When I think of restrictions, I need to look everywhere, anytime something was on the bottom. So the x plus 2 has always been on the bottom, so we know that x can't be negative 2. This x squared plus 5x originated on a bottom of a fraction, so if it were 0 at this point in time, it would cause a problem. And even though we've done some canceling since then, we do have to consider this, so x can't be negative 3 either. And then in the final statement, there's an x on the bottom, or an x squared, so x can't be 0. So x can't be negative 3, negative 2, or 0.